You ever get the feeling that you're gonna get completely destroyed by a coding challenge? Because I feel like day four has got to be the day. Yesterday was a little too easy, so I'm really scared. I'm disproportionately scared. Let's see how it goes. Day four, Advent of Elm. As always, I have not seen the problem yet, and we've got a little editor over here. Hello. I'm gonna be writing code on the left, and then we're gonna see the output on the right, and we're just gonna try to solve it step by step. Let's dive into it. Day four, printing department. You ride the escalator down to the printing department. They're clearly getting ready for Christmas. They have lots of large rolls of paper everywhere, and there's even a massive printer in the corner. Decorating here will be easy. They can make their own decorations. But what you really need is a way to get further into the North Pole base while all the elevators are offline. Actually, maybe we can help with that. One of the elves replies when you ask for help. We're pretty sure there's a cafeteria on the other side of the back wall. We could break through the wall, but you'd be able to keep moving. It's too bad all those forklifts are so busy moving those big rolls of paper around. I hope you like the voices. If you can optimize the work the forklifts are doing, maybe they would have time to spare to break through the wall. The rolls of paper, these at signs, are arranged on a large grid. The elves even have a helpful diagram, our puzzle input. I'm going to copy that, indicating where everything is located. So for this, it says the forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. If you can figure out which rolls of paper the forklifts can access, they'll spend less time looking and more time breaking down the wall to the cafeteria. In this example, there are 13 rolls of paper that can be accessed by a forklift. All right, there's 5 on the top. 6, 7, 8, 9, 10, 11, 12, 13. There are fewer than 4 rolls of paper. So here, there's 1, 2, 3. Here, there's 1, 2, 3. Here, there's 4 around it, so it doesn't work. Got it. Consider your complete diagram of the paper roll locations. How many rolls of paper can be accessed by a forklift? I think so far this is going to be not hard, but we'll see. See how it goes. I'm going to paste this in here, and we're going to get our crazy input. And what I'm going to do is I'm going to turn this into a 2D grid. I want to start by taking each of the rows one at a time. And it's kind of getting cut off because of the size of everything. So now that everything's in a line, what I want to do is I want to turn this into kind of like a coordinate space. So if I do indexed map with tuple.pair, what this is going to do is this is going to pair each one of these to a number to represent kind of the row offset. So for this first row, we're getting 0. The second row, we're going to get 1, and we're going to keep going for all of these 10 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. So that makes sense. So that's going to give us the rows, and then for each one of these, we're going to want to do the same thing to get the columns. So what I'm going to do is I'm actually going to do a concat map, and I'm going to say, basically, I want to know the location, like this is at 0, 0, this would be at 1, 0. And I want to know if it's empty or if it's got a paper towel roll. So I'm going to say to grid cell. And that is where we're going to start today's problem. We're going to take in, I'm just going to take the lines in one at a time. So this is going to take in a string, and for every row of text, we're going to return a list of these grid cells. And I'm going to make a little type alias here. A grid cell is going to be a pair where we have a coordinate, and we have kind of like what's at that spot. Let's see. Right now it's a Boolean. So what we could do is we could say, we could use a set instead of a dictionary. And we can just say, like, just give me all the coordinates that have paper towel rolls. That could work. So maybe for now we'll say we'll just do a Boolean. So the Boolean will be true if there's a paper towel roll there, and it'll be false otherwise. Let's see if we can get that working. So this is going to be a line. So we're going to take the line. We're going to do indexed map. As we saw before, these 0, 1s, 2s, and 3s, that is like the row that it's in. So I'm going to call that the y value. And then what we're going to do is we are going to take that y value. We're going to take one of these strings. So this is going to be row. I think I'm doing this wrong. Row is a string. Yeah, I want to pass in, I want to do this higher. So for each of these lines, I'm going to do that tuple pair that we had before. And this is going to give me the y here. I'm getting my data types a little mixed up. So yeah, so this is going to be an individual row. And then what I'm going to do is I'm going to turn the string.toList for that row contents. This is going to give me the row string. I'm going to turn that to a list of characters. And then I'm going to say list dot map. For each character, I want it to return true if the character equals at. Oops. And so this is going to give me a list of Booleans. Maybe I'll do that inside the index map. This will give me the x position, 0 through however wide this is. And then this will give me the character. And I'm going to return the coordinate. Coordinate isn't a built-in Elm type, so let's make it real quick. A coordinate is just going to be a pair of integers, the x position and the y position. And then we're going to say true if the character is this. I think that's okay. That's this. This great. So what this gave me is a list of these pairs. So here you'll see false, false, true, true. That represents dot, dot, at. And then we get dot, at, dot, at. And so what we're getting here is kind of these coordinates for each thing. So I think this is kind of the grid. And the idea of doing this is now I can turn this whole thing into a dictionary. So I'm going to import this is the dict module that comes with Elm. This comes with the core library. And dict from list is expecting something in this pattern where the key is this and the value is this. So when I run this through here, it's going to kind of look the same when I pretty print it. But what it's going to allow me to do is it's going to allow me to say like, hey, if I try to get the value at 0, 0, is that going to be true or false? And so here it's just false. So the reason I said maybe instead of a dictionary we can use a set is the true or false. Really, I don't think we really care about that as much as we care about like, is there a paper roll there? So what I'm going to do is I'm going to say, instead of using a dictionary here, I'm going to filter out the things that have the locations that have this character. So if the character is at, we're going to keep it around, otherwise we're not. And then what I'm going to do here is I'm just going to filter map, and if the value is a maybe, it'll return itself. And that should filter things. This returns a list of maybes. Filter map. Oh, and this returns a list of coordinates instead of a full grid cell. So here, this is just giving us all the coordinates that have the paper towel. So 2, 0, 3, 0, and then we don't see another one until 5, 0. And what's nice about this is I can use set.fromList. And so set allows me to do the same thing. Instead of saying dict.get, we can say set.member. So really, either way, should be okay. But here it's going to get rid of that maybe, it's going to get rid of that just. So here I get, yes, there is something at 0, 1. But there's not something at 0, 0, and there's not something at 1, 1. And if I do anything out of bounds, that's also gonna be false. So so I realized I did that, and now what I want to do is kind of loop through all of these things. This would have been easier if I left it as a dictionary because I would have been able to loop through all my keys and then query the neighbors. But this might help with performance. I don't know if I want to keep it as a set or a dictionary. So I showed you how to use a set. I'm going to go back to using a dictionary because I think this will be easier for me to be able to just loop through all the keys, because dictionary also comes with this really nice dict.keys module. So I can just loop through all these points and then query the points around them. So I can say count valid paper, what is it? Paper towels. So optimize the work. So this is gonna say accessible rolls of paper count. That's a weird variable name. Count accessible paper rolls. that's a bizarre function. So what I'm going to do here is I'm going to have this taken a dictionary. It's going to go from coordinate to Boolean, and the Boolean is going to mean like, is this a paper towel roll? And what I want to return is ultimately, I think a list of coordinates would be a good start. And then we can just say, give me the length of that list. Paper rolls. So if I just returned empty, then that's what it would return here. So I'm gonna comment this out so we can kind of make progress. What I want to do is I want to get all of the coordinates. So here, I'm going to start with all the coordinates. And then for each one of these coordinates, I'm going to loop. And initially, I'm going to have no paper towel rolls. Stop map. Maybe we'll do a filter map. Keep if accessible. Paper roll. And we're going to pass in that dictionary as kind of context because we're going to need to be able to read that. And so again, this is the dictionary that we're passing through. And then this is going to call it for every single coordinate. And it's going to return, I guess this can just be a filter. We can just keep that coordinate. And this can just return true or false. Am I a valid paper towel roll? So this is that. This is the X and the Y. We can do is we can make a little function like to neighbor coordinates. I'm just going to pass in the coordinate as one argument here. And so I'm going to say, let's get this. This is going to take a single coordinate and return a list of the neighbors. So this is where I'm going to destructure the X and the Y. And we are going to get all the 8 cells around it. So X minus 1, Y minus 1, And then this will be x, y minus 1. And this will be x plus 1, y minus 1. And this will be x minus 1 with y. And I'm kind of spacing it out in a fun way, in the way that you'd see it. This is kind of how my brain's visualizing it right now. Y plus 1, and these are all the different combinations that you might run into. So these are all the coordinates. I'm gonna hit format, and well, maybe I can kind of preserve the formatting like this. But these are like the 3 on the top, these are the 2 on both sides, and then these are the 3 on the bottom. So that's gonna give me a list of coordinates. And what I wanna do is I wanna count all of them that meet a certain criteria. And so the criteria is basically, if I try to use dict.get and I get a true, that means that it has a paper towel roll. So this is going to be neighbors, maybe a list of coordinates. I'm just going to kind of format this a little bit. And so what I want to do is I want to say, take the neighbors, and I think we can do, maybe do list.extra.count. Let's try that. List.extra count, is that a real function? No, I kind of made it up. Let's check out the docs. Yeah, count. Great. So we're going to count how many of these, and it's going to be just a slightly more efficient way to do this. So let's use that. So I'm going to count things where if you give me a neighbor coordinate, I'm going to say, if I try to get this neighbor and I plug in my dictionary, is that going to be true? Because that means that it is a paper towel roll. And so whatever that count is, it's accessible if the count is less than 4. I think that's what the problem said. Fewer than 4 rolls of paper. So what this should hopefully do is return all of the accessible. Oops, sorry, I forgot to do one other thing, which is only count if it is a paper towel roll. So I'll say if I'm just going to call this self. If I am a paper towel roll, then do this. Otherwise, this coordinate doesn't count. I guess that I didn't need to do it for everything. I just needed to loop through the one. So now I'm like going back to like, I should have left this as a set, but here we go. So what I have here is a list of all the coordinates. And we can do the same exact trick here. Instead of using filter, we can say list extra count. That should give us that 13. So that is the answer to this. I'm going to see if I can make this a set again. This is good practice. So what I'm going to do is I'm going to say if char equals at, then just xy, else nothing. We're going to get rid of this notion of a grid cell. This will return all the coordinates. For paper towels, that list.filter map trick to basically get rid of all the maybes. Before I did like an x to an x, but you can also do this identity function that's the same thing. The reason I'm doing this is because this will return a list of maybe coordinates, and so filter map is basically just going to drop all the nothing cases here. So I have that 2 coordinates with rolls. So we're going to do that, 2 coordinates with rolls, and we're going to do set from list. And then all of these are going to get simpler. We're just going to say set, do. And then instead of dict.get equals just true, we're going to be able to clean up a lot of this. In fact, we don't even need to do this because we know that the set will only ever have it. So this is an opportunity to clean up quite a bit of code here. And then this one's going to be member, true or false. I think this will still give us 13. Oops, not if I do it wrong. Set dot to list. Set. And I made up that variable name. Okay, so we still have the right answer. I just wanted to refactor that to use a set because I think that'll make life easier. The point where this can just take the list of coordinates. And for each of those, we can do that. And we can just do the set from list here. So that's gonna, by turning the list into a set, we're able to call these really convenient functions like set.member. And so list. So we'll be in a good spot there. Cool. Well, we got 13. Let me save this. I'm going to duplicate the tab. We're going to try it out with our puzzle input and see if that worked out. Wow, that's big. $13.84 is what I have here. Right answer. Okay, very cool. We're going to continue on to part 2 and see. Oops, that's me. Hello. And see what changed here. Now the elves just need help accessing as much of the paper as they can. Once a roll of paper can be accessed by a forklift, it can be removed. Once a roll of paper is removed, the forklifts might be able to access more rolls of paper, which they might also be able to remove. How many total rolls of paper could the elves remove if they keep repeating this process? Starting with the same example, here's one way you could remove as many rolls of paper as possible, using highlighted at to indicate that a roll of paper is about to be removed, and using X to indicate a roll of paper that was just removed. Interesting. Amazing. So I think we're just going to call this over and over again. But we're going to keep track of the items that we removed. So that list of coordinates that I was returning before, I think we're going to want those. How many rolls of paper in total can be removed by the elves in their forklifts? So yeah, I think we're just going to kind of do that same process that we had. I'm going to go ahead, undo this, compile, we're back to 13. And I'm going to name this part 2 before I forget. Collapse that, save this. So here I said, give me the, this is the count here. So I'm going to call this paper rolls removed. And what's cool is this, if I move that back to filter, this will give me all of the rolls that I'm able to remove. And so really, once I'm here, once I start here, I'm going to keep looping. So I'm going to loop until I can't remove anything. Loop until no more to remove. So this is going to take a list of coordinates for those paper towel rolls. I think that's right. Yeah, let's do it that way. And this is going to return a list of like how many we removed at each step. So the first time it runs loop until no more to remove. Original. I guess you can call this list. What I'm going to do is I'm basically going to call this. And previously, this was kind of our output. We just had 13, but we're going to keep going. So we're going to say the case or this is just a number. I guess this will always be a list. So in the case where there was none removed, we're done. And so we want to return how many we found. I think we're going to want to do this recursively. So I'm just going to keep those counts accumulating over time. And when we're in this case, when we have more than one, so this will be removed roles, what we're going to do is we're going to call this again. We're going to want to remove coordinates from here. So this is making me think that we want to make this we want to make this a set. And if we keep returning sets, if this whole thing is a set, I think we're going to be in a better place. Sets are just going to be easier to do unions and to remove a bunch of things. So I'm going to do the set from list once at the top, and I'm going to use set.filter. And I'm going to provide that set in as like the current state of the world. And so when I start with kind of the counts so far, what we're going to do is counts, and then I'm going to say list.length, or sorry, set.size, removed. I'm just going to add it. I think count is just going to be an integer. So initially we have 0 removed. And we're going to try to return an integer. So let's set equals this if set dot is empty. And this is going to be called removed. Sorry, I'm doing all this like all at once here. Removed equals paper rolls removed. That returns a set. So let's annotate that. Set int. If the set is empty, basically if I didn't remove anything, let's make the count, just return whatever count we had. So initially it'll be 0. So if in the beginning I can't do anything, it's just going to return 0. Otherwise, we're going to keep looping. We're going to add to our count however many we removed, and then we're going to pass in set what is the function for diffing? Get the difference between the first and the set. Keep values that do not appear in the second set. So we're going to diff our existing with the removed, and I think that's going to subtract out what we expect. So diff, this is going to be, I'm going to call this original with the removed, and we're going to pass that in as our new set. Oops, this is a set of coordinates. 43, is that the answer here? 43. Okay, well that looks good. I could break this into a smaller thing so we can see like the 13, the 12, and the whatever. But I'm going to do that if we get to the part where it's not working and we want to debug it. So I'm going to save this. I'm going to duplicate this. And then I'm going to try it with my puzzle input. And we're going to see if the performance on this is okay. 8013. Let's try it out. That's 2 stars. That was easier than I thought. I think there were a lot of opportunities in the code where I could have started like growing big lists of things, and a lot of those places I chose to use an integer. And you saw the browser kind of freeze for a little bit when I ran it. I think it would have freezed for a lot longer if we weren't keeping that count as an int. So there were a few places that I think we dodged a bullet there. I'm curious if the browser would have stalled out if we didn't do those things. Maybe it wouldn't have. But yeah, that was day 4. We have 8 stars under our belt. So that's pretty sick. I always like to try to get to, at least 7 days. Hopefully I can do that this year. Maybe day 5 is when the ball drops and everything's terrifying, but it wasn't today, so that feels good. Yeah, thanks for watching, and I'll catch you tomorrow.